So if you look at this flow chart of energy equivalency, so being able to work from all the way from METs to VO2 in milliliters per kilogram per minute, to VO2 in milliliters per minute, to VO2 in liters per minute. And you may not have realized this, that if you have VO2 in liters per minute, 1 liter of O2 is 5 kcals. So you can get kilocalories per minute. And then if you know the number of minutes that someone is exercising, so say 45 minutes, then you can get total kcals per session. And then if you use the estimation, again, 3,500 calories per pound of body weight, per pound of body fat, you can get a pound of fat. So you can these are all different ways to express energy, and sometimes people miss that. You know, it's energy, whether it's calories, whether it's VO2 in liters per minute, whether it's MET or milliliters per kilogram per minute. These are all different ways to express energy. So you want to feel very comfortable with that. This is a nice chart. It was actually done by my master's advisor, Dr. Beebe. This was in a previous edition of the ACSM study guide. So here are these conversion factors to know. A lot of these you should know from your exercise phys labs, from your work and power. So I mean, Ex-Phys 1 spend a whole semester on work and power for the most part, and in some of your other classes. So as I mentioned about the 1 mile an hour per meter per minute, you know, the conversion multiplied by 26.8% grade. That is the incline on the treadmill. You got to convert to a decimal. Again, METs, liters, kilograms, inch to centimeters, a foot to meters, a kilopond, a kp, is the same as a kilogram. 1 watt, 6.12 kgms per minute, or kpms per minute. Sometimes you might see that estimated just to 6. 1 revolution on the Monarch cycle ergometers. You'll need that. So if the bike was to actually travel, every time you pedaled, you would move 6 meters. And then 1 revolution on the Monarch arm ergometer, like we have in the lab downstairs. We don't use that very much, 2.4 meters. And I think most people are familiar with a pound of fat as being 3,500 kilocalories. Again, energy is kilocalories, or calories with a capital C, that we typically use in exercise phys. Again, people use, you know, all of them interchangeably, small c's for calories, but really our energy expression is kilocalories. So the ACSM walking equation, you can see I've bolded these to get the total VO2, a horizontal, the vertical, and the resting. So to calculate your VO2 for the horizontal component, you've got to get your speed in meters per minute. So miles an hour times 26.8. Then you have to add your vertical component. So 1.8 is just a constant. 0.1 is just a constant in the formula. Then you plug in your numbers and you calculate. Your speed, again, has to be meters per minute, and the grade has to be a decimal. And then you add your resting component, which is easy because that's 3.5 milliliters per kilogram per minute. So add up your horizontal, your vertical, and your resting to get your total VO2. There's no reason why you can't get this type of straightforward calculation correct. So now let's look at this example, walking at a 0% grade, 3 miles an hour. First thing I'm going to do is convert 3 miles an hour to meters per minute. And then you can see I multiply that by 0.1, and I get 8.04 milliliters per kilogram per minute. My vertical component is 0 since it's a 0% grade, so a flat surface. And then you always add your resting 3.5. So my total VO2, the horizontal, the vertical, and resting, 11.54 milliliters per kilogram per minute. They may ask you for METs. And so if so, you divide by 3.5. So it is about 3.3 mets. So yeah, you should feel pretty comfortable with this one. Again, you know, it's okay that you may see some slight rounding errors. Since it is a multiple choice exam, choose the answer that is the closest.